we have page 2 of the 7th grade post-course for 7th grade advanced, We have this situation. Triangle A has an interior angle measures of 108, x, and 37 degrees. So triangle A, so we've got this, let's make it green. Triangle A has 108, x, and 37. These are not drawn to scale because that looks like an acute angle, and 108 would be an obtuse angle. But we would add them up. They're going to add up to 180 degrees. So we make this equation. And we got 145 plus x equals 180 minus 145 minus 145. X is going to equal 35 degrees. And then we have our other triangle, which is 108. We can put that y, and we can put 35 here. And logically, we know that it's going to be the same triangle, but we can do the same thing. 108 plus 35 plus y equals 108, or 180, excuse me. 180, that gives us 143 plus y equals 180 minus 143 minus 143 gives us a measure of 37 degrees. So we have a triangle here that would be 37, 35, 108. And then we have a triangle here that is 108, 35, and 37. So are the triangles similar? Yes, they are. They are identical and similar. The profit Y in dollars for a business from selling X hats is represented by Y equals 9X, where Y is the dollars that you make and X is the number of hats. Graph the equation. So we're going to use our fixed here. So if we look at this data, you have input, you have output. So X represents the number of hats. Y equals profit into this equation. If we sell one hat, if we sell 0 hats, we get 0 profit. 0 times 9 is 0. If we sell 1 hat, we make $9. 2 hats, 18. 3 hats, going to be 27, etc. Dot, 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 dot. So we can make dot. It's going to be 1, 9. Oh, we'll do these in increments of 5 on the y-axis. So that's 1, 9, 2, 18, 3, 27. Nope, that would be, 27, that's right, 27. And they're going to be dots. They are not, it shouldn't be. So in the answer key, it shows that it is continuous. It is not. It is discrete, I think is what it is, because you can't sell half of a hat. So you actually can't connect the dots. You would do 4, 36. So what's that? 10, 20, 30. So you'd have that. You make a dot. 5 is going to be 45. So we would go to here and be on there. But you would only have dots, and your x-axis is number of hats. Your y-axis is your profit. But you cannot connect those because you can't have partial hats. You're not selling a half of a hat. So if you connect it, you're saying that all of them are possible solutions. So the book actually made a mistake on that one. All right, number 18. The distance y in miles that train A travels in x hours is represented by the equation y equals 64x. The distance train B travels is represented by the graph of a line through the point 0, 0, 160. Which train is faster? So when you take your first train A in the equation y equals 64x, so after 0 hours, so this is x represents hours, y equals distance. After 0 hours, you go 0 distance. 1 hour, you go 64 miles. 2 hours, you go 128 miles. And then we have, so technically, if this is the unit rate, it is going to be 64 miles in 1 hour. So train B, well, you have the point 0016, x, y, 0, 0, 1 hour, you travel 60 miles. 2 hours, you travel 120 miles. And so this train's formula is y equals 60x. So train A is faster because it goes 64 miles in 1 hour. Train A is faster, going 64 miles per hour. That's a good one. Number 19, solve the system by graphing. We're going to go back to our graph. So these are two lines. This is, lines can be written in slope-intercept form. That is y equals mx plus b. It can be in standard form. Standard form is ax plus by equals c, and then it can be in point slope form, and point slope is y minus y sub 1 equals it's been a minute, m times the quantity x minus x sub 1. And so slope, here's your slope, here's your y-intercept. Here are your two intercepts. You have a trick of finding the x and y intercepts, and then point slope, you have a point and you have the slope. So slope-intercept form, this is a y-intercept of 4, 1, 2, 3, 4 on the y-axis, and then has a slope of 3. So it's going to go up 1, 2, 3, right 1, 1, 2, 3, right 1, and then we have a line. So we'll connect those dots. Connect those as best as possible. Put some arrows on it. We'll do this one. Now this is in standard form, so we could, but the intercepts are a little bit more challenging. The y-intercept is -4. The x-intercept is actually -4/5, but it's probably a whole lot easier just to put it in slope-intercept form. And we can pull out the y-intercept, which is -4, 1, 2, 3, 4, and my slope, which is down 5, right 1, -5, 1, 2, 3, 4, 5, 1. Or we can go up 1, 2, 3, 4, 5, and left 1. And in extending it in both directions, you're actually able to see the point of intersection. And the point of intersection is a solution that they share, which is the solution to the system. So we want to know what value do they both share as a solution. All these points on the green are solutions for that equation. All the points on the blue are all the solutions to this equation. So they are going to share this solution. That is a solution that they, that was not good. Let's not do that one. That they both share. So that point or location is -1, 1. If we plugged it into both of them, you would get true statements for them. So solve the system. The solution is -1, 1. Love systems. Solve the system algebraically. So much like there were 3 different types of lines or forms for lines. There are multiple ways to solve systems. Substitution, which is the one we're going to use today. Substitution. You have addition and subtraction. And then you have, it's kind of like multiplication or proportions. Proportions, you can do it in that manner and then apply addition and subtraction. We're going to use substitution. We're going to take, and the reason we do substitution is we have y isolated in terms of x's. So where we see the y in the other equation, we're going to substitute that value in for y. We can't solve either of these because we have two variables. Whenever you have two variables, you can't cancel them. So we're going to take this equation 7x minus 6. Instead of writing y, we're going to put what y is equal to, negative 5x plus 7. And then we're going to continue with this equation. So we're just rewriting it. And both of these equations have two variables. And you notice that this equation only has one. We've gotten rid of the y. So now we can simplify and isolate the variable. So 7x, we have negative 6, which is going to multiply by negative 5x. And then we have negative 6 that is going to multiply by positive 7. Now we're going to simplify this. This is positive 30x. This is negative 42. And much like on page 1, always simplify first. Simplify both sides of the equation. We have like terms here. So we have 7x and 30x, which makes 37x minus 42 equals negative 5. We've consolidated the variables. Now we're going to move the constants. So we will get rid of that negative 42 by adding 42. And what we do to one side, we have to do to the other. This leaves us with 37x equals, that's going to give us positive 37. We're going to divide by 37. And we're left with x equals 1. Now that is only part of the solution. Remember, the solution has two variables. So I have found the solution for x. I'm going to use this equation. I'm going to use this, and I am going to, let's erase that simplify. I'm going to use the equation y equals negative 5x plus 7, because I still need to find out what y is. I know what x is. Remember, x was 1, so I'll substitute that in. Y equals negative 5 plus 7. Y equals 2. And so I have my x value. I have my y value. So the solution is a point, and that point, or the solution is a common solution between those two equations, is 1, 2. That is a solution to both of those equations. You buy 4 health bars and 2 health drinks for $14. Your friend buys 5 health bars and 3 health drinks for $19. How much does each item cost? So we have to first write an equation for the first statement. So 4 health bars plus 2 health drinks equals $14. So we wrote that information as an equation. And then your friend buys 5 health bars and 3 health drinks for $19. And that is good. Now, we are going to use addition and subtraction, but they don't cancel right at the moment. So we're going to multiply first. So we're going to multiply. And let's say I want to cancel the b's. So I need to have a common multiple for that. They actually have to be opposite. So I'm going to multiply this by 5 and this bottom equation by negative 4. If I multiply everything, it creates an equivalent equation. So 5 times 4b is 20b. 5 times 2d is 10d. And 5 times 14 gives me 70. Negative 4 times 5b is negative 20b. Negative 4 times 3d is negative 12d. And negative 4 times 19 is going to give me negative, I almost did positive, negative 76. Negative 76. Okay, now we're going to add these. Notice they are aligned. The B's are aligned. The D's are aligned. They're both on the same side of the equal sign, and my constant is on the right. If I combine these, they cancel out one of the variables, and it leaves me with negative 2D equals negative 6. We're going to divide by negative 2. And we're left with D equals 3. So we bought 3 drinks. Drinks are $3. So drinks are $3. And then I can pick any of these to figure out what my the bars are. So I'm going to use the top equation for B plus 2D equals 14. I'm going to plug in $3 for D equals 14. We're going to simplify before moving. Minus 6 minus 6. 4B equals 8. We're going to divide by 2, or divide by 4 to get 2. And B equals $2. So bars are $2 a piece. And drinks are $3 a piece. Kind of neat how we can utilize systems of equations in order to solve real world problems. Determine the number of solutions in the system. So when you have 2 lines on a graph, if you have 2 lines on a graph, they can intersect and have 1 point of intersection. That's one solution. You can have another situation where the lines are parallel to each other and they will not intersect. So you have no solutions, no intersecting points. You have 1, no, and then the last situation, which is a little bit tricky, is if they're the same line. And if they're on top of each other, they have an infinite many solutions. And I don't like that answer. Mr. Mack always says all points on the line. All points on the line. That's where they intersect. Notice that when they intersect in one solution, it's a location. We give that coordinate. So when we have infinite many solutions, I like all points on the line because infinite many solutions doesn't tell you where. All points on the line tells you where. And so how do we get 1 no solution? So if we don't want to add these at the moment, we want them to cancel. So we're going to manipulate the top equation. That makes negative x minus 4y equals negative 6. Don't forget to multiply it all out. We don't have to manipulate the bottom one because we see that that's going to cancel some stuff. We add, that's canceled. So 0 equals negative 1. That's a false statement. And a false statement is no solution, meaning they're parallel. So false is no solution. If your number statement is false, the answer is no solution. No points intersect. There are no solution that they share they don't share any solutions. If this was true, it would be infinite many. And if it was one solution, they would not cancel out. You'd still have an x and a y. So 22 is going to be no solution or none. There are no solutions to it. All right. I put this here. I thought that was important to share what outliers, clusters, and gaps are. So it says identify any outliers. Well, let's look at this first point. It's labeled A. A would be considered an outlier. An outlier represents an unusual value that deviate from the general pattern. Our general pattern is through here. So A is definitely an outlier. Is a data point that is significantly different from the rest of the data. Point B, I don't know where point B is, but It's one of these points. But point B would be considered a gap. So we have outlier, we have gap. A gap is an area or interval on the graph where there are no data points indicated. A break of absence, so B is a gap, and so indicates where data is missing or infrequent. Yeah, it's infrequent here. And then clusters, yeah, C is going to be clusters. That makes sense. It looks like where the data is grouping, we're located close together, and there you go. So we have an outlier, we have a gap, and we have a cluster. Describe the relationship between the data in the scatter plot. So when we're describing scatter plots, first of all, scatter plot is a graph that visually displays the relationship between two sets of data. We have X and we have Y. I don't know what X represents. I don't know what Y represents. The data is plotted in ordered pairs. These are X comma Y's. And the scatter plot help identify trends. Yeah, we see this trend along here. So describe the relationship between the data in the plot. Well, it's considered, so how do we analyze it? Form, direction, identifying correlations. Positive correlation, so if it's increasing X as we increase Y, says as the X values increase, the Y values also tend to increase. This is indication of a positive slope. Yeah, it's going up to the right. Negative would go down. No correlation would be no discernible pattern. It would be very wild. So this, if we were going to describe the relation, we would say it would have a positive correlation. Okay. And then we have other stuff analyzing key features, form, direction, strength, outliers, using lines of fit. Sometimes we have to write an equation for that, like in this one. Make a scatter plot of the data and then draw a line of fit, write an equation of the line of fit. Okay, so if we plot these points, we will go in increments of 5. So 10 on the X, 15 on the Y, and 20 on the X, and 20 on the 1, 2, 3, 4, 1, 2, 3. Oh, there we go. Sorry. 2020 is going to be here, right? Yes. 15, 5, 10, 15, 20. Okay. 2025, 1, 2, 3, 4, and that's going to be 5. So 2025, 40, hi, 5, 10, 15, 20, 25, 30, 35, 40, 45. So 40, 45 is going to be that. 2015, 1, 2, 3, 4, 1, 2, 3. 10, 5 is going to be that. 40, 40. So 40, 40 is going to be this. 5, 5 is going to be this. And 25, 25, I think, is this. 1, 2, 3, 4, 5. No, that's down one more. Sorry. 25, 25. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So there is our data. Let's draw a line. Blue's good. So we're going to draw a line of fit, kind of like that. That looks pretty good. We're going to put arrows on it. And that kind of looks like a slope of 1. So that equation would be y equals x. So plug in 5, you get 5. Yeah, there were multiple ones that sort of hit that data points also. 40, 40, 25, 25, 5, 5, 20, 20. So 4 of those data pieces lay right on that line of fit. Okay, so that would be your equation for your line of fit. And that's it. Wow. Okay. That was pretty good. That wasn't too bad of a worksheet. Have a good one.